Hello and welcome to our time going through Chapter 11 homework problems. We're going to start off with the questions that we have, the conceptual questions. The first one, pretty straightforward. Approximately how does the density of air vary with altitude? I think you already know that the higher up you go, the less dense the air is. Why is that? Why is the air thinner higher up? Well, because there's less weight pushing down on it. The air on top of us is this giant stack of air. And later on we'll talk about compressible versus incompressible fluids. But air is one of those compressible fluids. You can compress it until it turns into a liquid. Well, air higher up is less compressed, less dense. There's a little more space, a little more energy, a little more of the sun's energy going in. So the air molecules are bouncing around faster. Goes down, decreases. Number 7 was an interesting question. We talked about a glass of water that's filled all the way to the brim with water, but then it's got ice cubes that are actually physically stacked in there so that some of the ice surface is sticking out of the top. And the question was, will the water overflow when the ice melts? And to explain your answer, I went through plugging in numbers in a way to try to come up with a answer that I could really buy into, and I can buy into it. The volume of the ice, remember density equals mass over volume. The volume of the ice then equals volume mass over density. So let's say that we have 1 kilogram of ice sitting there in the water. All right, it's a huge glass of water. Deal with it. If we have 1 kilogram of ice, that's going to be a volume, kilogram per cubic meter. The density of ice is 917 kilograms per cubic meter. That's going to be a volume of ice of 1.09 times 10 to the negative third cubic meters. Now, why we care about that is that according to our understanding of buoyant force, the ice floats in the water when it displaces its own weight in water. And the weight of the ice is equal to the mass, or corresponds to the mass of the ice. So this 1.09 times 10 to the negative third cubic meters of ice is displacing a volume in water of 1 times 10 to the negative third cubic meters, because the density of water is 1,000 kilograms per cubic meter. So in order to displace 1 kilogram worth of water, it's going to be this volume. You can't see my finger. That volume of water. That means that when the ice melts and turns back into water, there's going to be an extra 9 times 10 to the negative third cubic meters of volume of stuff, because the ice is less dense, but then it turns into water, which is more dense. We're going to have more ice in there, and it's going to overflow the container. You can try this at home, but you'll get confused because of condensation. Finally, number 30, we have the question of whether the same ship will float higher in salt water than it does in fresh water. The same ship displaces the same mass in water. So if our 100,000 kilogram ship, in order to float, displaces 100,000 kilograms of water, that volume of water, volume of seawater, the volume would be 100,000 kilograms divided by the density of seawater. You have to look that up somewhere. It's 1,025 kilograms per cubic meter. So that ship will be displacing 97 cubic meters of seawater versus same deal, volume of fresh water. 100,000 divided by 1,000 kilograms per cubic meter. 100 cubic meters. Sorry. So what does that mean? That means that the ship starts floating once it sinks into the water enough to displace 100 cubic meters of fresh water. So it's sitting lower in the water, and only 97 cubic meters of seawater, so it's riding higher. So the question is, will the same ship float higher in salt water than in fresh water? Why, yes. Yes, it will.